Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I am going to show you a model which can do this. This is where you provided three images on the left hand side and a text prompt, and then it customizes those images to produce this result where this character is standing on top of a mountain, sunset in the background, realistic shot. This has all come from a text prompt which has customized these three sample images. We are going to install it locally, and then in the similar Gradio demo we will see how it works. Before that, let's have a quick look at this project. The cool thing is that this has been done by a student, as you can see, and it was a model which was created at the end of the internship. So pretty impressive, I would say, in that sense. So what exactly is happening in this model? So this model is a new approach to improve text to image model customization. There are three parts to it. First and foremost, there is this synthetic customization dataset, or SynCD, which is a high quality dataset generated using existing text to image models and 3D datasets that consist of multiple images of the same object in different lighting, backgrounds and poses. And then they have got a new encoder architecture, which is a shared attention mechanism based encoder that better incorporates fine-grained visual details from input images. Then we have a normalization technique that mitigates overexposure issues during inference by normalizing the text and image guidance vectors. They have shared a lot of benchmarking details in their paper, which you can also access from their GitHub repo. If you look at this model architecture, this tells you a bit more around how exactly they have created it. So they have fine-tuned a pre-trained IP adapter based model with the global feature injection on their generated dataset, which I mentioned earlier, the SynCD. During training, they additionally employed masked share attention, or MSA, between target and reference features of the image. This helps the model to incorporate more fine-grained features from multiple references images during inference. And then they have shared a lot of detail around their data pipeline. So their dataset generation pipeline is tailored for deformable categories, where they have used descriptive prompts and masked share attention, as I mentioned earlier, among foreground objects region of the images to promote visual consistency. Also, in the bottom section, you see this rigid object generation, where they have additionally employed depth and cross view warping using existing observers assets to ensure 3D multi-view consistency. They have also used Dino V2, which we already have covered on the channel, and aesthetic score to filter out low quality images to create their final training dataset. So that is the whole intro around this model. Let's try to get it installed and we will see how it works. Let me also give a huge shout out to Mast Compute, who are sponsoring this VM and this GPU for this video. If you're looking to rent a GPU on very affordable prices, you can find the link to their website in video's description with a discount coupon code of 50% for range of GPUs. You can see that I'm creating this virtual environment with Conda, and then I'm going to git clone the repo of SynCD, and as I said, I will drop the link to it in video's description. And then all you need to do is to run this command. This is going to launch the Gradio demo in the browser. So let me quickly run this. And the first time when we run it, you see that it is downloading the model. So let's wait for it to get downloaded. The size is just under, I guess the first shard is 10 gig. And now it is running on our local system at port 7860. So let me open it in the browser. Before I do that, let me also introduce you to the sponsors of this video, who are Camel AI. Camel is an open source community focused on building multi-agents infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. And there you go. So SynCD is running on our local system. Let me also show you the VRAM consumption in real time. So it is just consuming close to 33 gig of VRAM. So make sure that you have that much of VRAM on your system. Let's try to play around with it. Let me make it a bit smaller maybe. So first I'll just scroll down and then select one of their examples. So I'm just maybe go with second one. Let's, okay, I clicked it. What happened there? Sorry, let me click it again. Let's wait for it. So first time just takes a bit of a time. So you see that there are these three images. I'm just going to fit it on the screen. So these are the three images, and the text prompt was: a penguin plushie wearing pink sunglasses is lounging on beach, realistic shot. So you see, these are the pink sunglasses, as you can see here. You can also maybe change the color here. I can say maybe red sunglasses, and then there are a few parameters which you can set, but I'm not just going to use it. I'll just use it with this one. Let's wait for it. And there you go. So it has produced it, but you see that the glasses are not on the eyes. So, and I am showing you as is. Maybe we can play around with this guidance scale. Maybe I'll just increase it. Just guidance scales normally guides the model to follow the prompt as is. So I'll just run it one more time to see what it does. Maybe I'll just increase it a bit more. I'll just go to 5. Normally I keep it to 6 or 7, but anyway, see if it is the same guidance scale they are using, which we use with Flux. So let's see what it does this time. And there you go, slightly better, but I think still we can play around with, maybe we can set the seed or just randomize it. Maybe I'll just make it 40 for the last try, and I'll click on generate to see what happens here. Let's wait for it. And there you go, you see, much better than before. Now it is, could be better, but I think it is on the right track anyway. So let me give it my own images from my local system and a text prompt to see how it works. Now in this example I have given it 3 images of myself, which is my idea of modeling, and then the text prompt is that a man on top of a mountain, sunset in the background, realistic shot. Let's see what it does. It is, should be fun. And there you go, totally wrong. I mean, there is no, I mean, yes, background is right, mountain top is right, but the main attraction, I would say the main object, primary focus is not cool. Even the shirt is not right. The color is right, and the hand is it is trying to take the cue from my hand, but other than that, no, it doesn't look good. Okay, maybe I will just uncheck this rigid object. I will move this to back, and I'll just reduce it to maybe 3.6, and I'll just change the seed to like this. Maybe I'll just randomize it, slightly random, very there you go. Let's do it now, one last try, and check this one out. Okay, so this is very unlike me. I don't even, I mean, I don't know where it is getting the beard from. Okay, so I'm not going to comment on this one. I don't think so this is good enough. So I think it doesn't really work well with the human figures maybe. And because if I just select this example from the end, it, and the first time when you select it, I think it loads the example. So you see, it is just loading the example. I think so. Let's wait for it. So once it is loaded, I'll just run it. And there you go. So for this one, it works well. So let me just select, my own static images like something like this, and we will try it out. So I have just created these images from AI, and then these enemy girl images, 3 of the same one, and I am just asking it to do enemy girl on a beach, waves in the background, realistic shot. Let's see what it produces. I hope that it is a censored one. And there you go. So I believe much better than the previous one. So it seems that it doesn't work really good with humans, but for rest of the objects works well. So I'll just go down a bit maybe I will just play around with these prompts here, and maybe I'll increase inference steps and give this bit more randomization, and then let's click here to see what it generates. Let's wait for it to come back. Takes around a minute or so, as you can see here. And that's it, much better. Still, I think could be improved a lot, but I think we would have to play around with the prompt, maybe some of the settings, and then it might generate a better one. I'm not sure why model is much geared towards bit of a healthy ones anyway. So I will let you to figure that out. I will drop the link to it in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it really helps a lot. Thank you for watching.